Assalamualaikum and good day. Today we're going to continue on the part 2 of the week 6 lecture slides on wired communication system. On the part 1, we have covered until the durability, which is at the slide of number 21. Okay, now we go to the next slides. Okay, Assalamualaikum and good day. So we're going to continue on the part 2 of the chapter 6 wire communication system slides. Okay, so we go with the examples here. We can see a video signal is transmitted over a coaxial cable with an attenuation of 10 dB per kilometer. So means the signal is being degraded, okay, with 10 dB over 1 kilometer distance. So if we're going to have 2 kilometer distance, the signal is going to attenuated by 20 dB per 2 kilometer. Okay. If the signal power at the transmitter is 50 milliwatt, find the power received after 10 kilometer. Okay, means it has been given here total. Okay, total distance is given as 10 kilometer. Okay, and then attenuation has been given. Okay, our attenuation has been given as the 10 dB per kilometer. So what we can see is that we can actually directly calculate our total attenuations. Okay, total attenuation, which is 10 dB per 1 kilometer times with the total distance that has been going. Okay, which is so this one you can cancel out. So you're going to have 100 dB. Okay, and then after that, if the signal power at the transmitter is given as, okay, power at the transmitter is given by 50 milliwatts. Okay, so what, find the power received after 10 kilometer of um, distance. Okay, so x, we don't know, this is what we're going to find. So from the equations of loss in terms of the decibel, okay, so it is equivalent to 10 log PTR transmitted over P received. Okay, so if we want to solve this, the question is asking find the power received after 10 kilometer, means the question doesn't specify whether the power have to be expressed in decibels or have to be expressed in watts. So here the answer is quite flexible in terms of the format. Okay, whether it's want to be in dB or linear. So let's say we want the answer to be stated in linear. So the equation that we have here is actually in the decibels. So we have to make some arrangements, okay, so that the answer will be in linear. Okay, again, the question didn't specify us to answer in decibel or linear. Okay, but now for the sake of exploring many kinds of answers that we can give from one single decibel equation, so we're going to rearrange this. Okay, so here we have a P receive, right? We rearrange the signal, the equation above. P receive equals to P transmit, okay, times with 10, the loss in the dB scale, okay, over 10. So this actually is a conversion, okay, conversion from dB to linear. Okay, so after that we put the equation that we have, the value that we have. We know the P transmitted is 50 milliwatts. Okay, times with 10 negative loss we have known. The loss is system of 100, so negative 100 over 10. Okay, so you press your calculator, you will come across the total value will be 591. So this is the total power or the power received after 10 kilometer, which is 5 nanowatts. Okay, so we go to the next slides. So this is the schematic answer. Okay, you can try to see and compare between the two. Okay, so this is the examples. I leave it for you to try. Okay, and the answers for it is just at the next page. Okay, now we continue. Summary of the characteristics of the cable that we have learned so far. So we have learned so far from the previous week 5 chapter slides and also on this current week 6. So now we come to across how to summarize between these three types of cables, which is twisted pair, coaxial cable, and fiber optics. So we may compare them in terms of bandwidth, electromagnetic interference immunity, attenuation, the cause, and signal types. So based on the bandwidth, we can see that the fiber optics, okay, able to provide more bandwidth. Immunity, the fiber optic has the most immunity to the EMI. So this one is, pretty much understandable. Okay, attenuations. For fiber optics, it has the lowest attenuation, whereas the twisted pair has the highest out of the three. However, in terms of the cost, twisted pair is much more cheaper compared to the other two types of cables. In terms of the signal type, for the twisted pair and coaxial cables, it is electrical and electrical, and then the fiber optics here is optical. Okay, so here, the coaxial cable here is also can be in terms of the electromagnetic. Okay, so you can add information to here. Okay, the coaxial cable is in terms of the also in terms of electromagnetics. Okay, now we go to the next slides. So now we go to the this another part of this week 6 chapter, which is the signal propagation in wired communication. So this the words propagation means how our signal behave, how our signal is being behave when it's transmitted from one distance, from one transmitter to receiver to the receiver, how the signals is actually going through or behave in along the way. Okay, so general concept, signal propagation means how the information carrying signals, either is electrical, electromagnetics, or optical, travel from transmitter to the receiver through a transmission medium. Okay, here we can add EM wave. Okay, electromagnetics. Okay, in wired system, the medium is usually copper for electrical signals, optical fiber for light. For wireless communications, okay, you may add up is in terms of electromagnetic wave. Although current flow in a conductor, the actual communication energy travels through the electromagnetic field that surround the wire. Okay, actually, what you have learned from your previous subject, EMT, whenever there is alternating current, okay, whenever there is AC, there will be electromagnetic wave. So electromagnetic wave is not only limited to wireless communications. Okay, so that one we have to bear in mind. Okay, mechanism of signal propagation in cables. When a voltage signal is applied to one end of the cable, so for here, let's imagine it's a transmitter. Okay, electron moves slowly in the conductor, so we call it the drift velocity, a few millimeter per second. So I believe that you have heard on this term previously before this subject, which is electromagnetic field theory, where you have been introduced last time, maybe not detailed about the drift velocities. However, the electromagnetic field generated by the voltage and current move almost at the speed of light through the surrounding dielectrics. This field carries the information and induces current in the next section of wire, allowing the signal to propagate or to move forward. Signal propagation in the twisted cable, okay, in the twisted cable pair, so means it's actually we have one of the cable is being positive and one of the cable is negative. So together they create a differential signals. The twisting of the wires, okay, balance the EM field, reduces the external EMI, minimize crosstalk between the adjacent pair. Okay, the electric field is mostly confined between the two conductors that is being twisted with one another. Signal propagations in the coaxial cable structure: central conductor, dielectric insulator, outer metallic shield. So this we have learned previously, right? The coaxial cable. So everything is actually on the same axis. Thus the name is coaxial. Okay. The signals propagate in the space dielectric between the inner and the outer conductor. The shield prevents signal radiation towards the outer environments and protect also from the external noise. So our shield actually plays two important functions, okay, to reduce the signal leakage, okay, in terms of the radiation outward, and also to protect the our uh, signals being transmitted from this being disturbed by the external noise. So thus it acts as a waveguide, confine the electromagnetic field perfectly. So twisted pair, coaxial cable, and optical fiber is a type of guided communication system. So we have the unguided, one of them is the wireless. Next, signal propagations in the optical fiber. Signal propagate as light wave. So our signals is being transmitted in the form of lights. The core, higher refractive index and cladding, lower refracting index, will produce a signals that is propagated in terms of light will experience the total internal reflection. So it's like a mirror, okay? So the signals, they will be reflected from one surface to another as it propagates from a transmitter to the receiver. So this is the figures, okay? It's how actually our signals, okay, in terms of light, behave when it is being transmitted over optical fiber from the transmitter towards the receiver. So this is the formula of the signals propagation, of which some you have learned previously, which is this. Okay, you have learned this from the previous second year subject, which is the EMT, right? So signal propagation along a transmission line is governed by the transmission line equation, voltage and current along the line, where Vz is equal to V naught epsilon exponent E gamma Z, Iz equals to I naught E negative gamma Z. So I naught is actually the amplitude, okay? V naught is also the amplitude, okay? Y equals to alpha plus J beta. So where your alpha is actually the attenuation constant and beta is the your phase constant. Together, this equation produce a propagation constant. Okay. Repeater in wired communication system. So by the word repeater, you can see that something is being repeated or something is being reproduced again. Okay. Or something is being recycled, or in terms of there will be another cycle. So this is the words repeater, right? So in communication system, we're going to also to have some repeater, okay? And this repeater is not unique in wired communication. It also will also have in wireless communications. Okay, but since we are actually covering week 6 for wired communications, let us see the repeater in the wired communications. Okay, next. So the definitions of repeater. Repeater is an electronic device that receives a weakened or distorted signals, amplifies or regenerate, and then retransmit it at or near its original strength and quality. In telecommunication, a repeater is an electronic device that receives a signal and retransmit it. Okay. So by here we can see that actually the repeater help us to reproduce the signals that is disturbed by noise or weakened or distorted, okay, after it being received by from the transmitter after go through several distance and retransmitted it, okay, along the way as the signal is still propagating towards the receiver. So do take note that repeater did not change any information. Okay, repeater is not supposed to change anything of the signals. Okay, means information is remain intact, but the strength, the quality of the signal strength, okay, being transmitted is being reproduced again or re-strengthened again as it is being weakened or distorted by noise and other external factors while it's being propagated from the transmitter. Okay, so the purpose of the repeater to overcome attenuations that has been gone through by the signals after going through several distance to maintain signal integrity, to prevent the distortion and the noise build up, just like what I told just now, and then to extend the range of the communication system by having repeaters, okay, in between of the transmitter and receiver. Our signal can be transmit at further distance by re-energizing, by re-strengthen the signal that is being transmitted, okay, from the transmitter. Next, working principles of the repeater. When a signals travel through a wires, okay, for example copper fiber or coaxial cable, it gradually will lose amplitude, okay, due to attenuation. So this is the V naught and I naught of the equation that that you have seen just now, get distorted due to dispersion, pick up noise along the way. So the noise can be from the electromagnetic interference, can be external factors, can be also the noise that is coming along the way from the system to another. A repeater receive the incoming weak signal, amplify or regenerate it back to the original signal, transmit it onward to the next segment. So this is the extended, okay, the summary of wired communication system. So you can go brush through all of them. This will help you to answer or to help you understand, okay, all the differences or all the similarities or all the distinguished factors, okay, based on the definition, types of wired media, characteristic of wired media, attenuation, signal power calculation, noise susceptibility, reducing noise, propagation speed, propagation delay, wavelength in cable, repeaters, type of repeaters, importance of repeaters, and relationship summaries for for all of the cables that we have learned. Okay, next. Important takeaways. Okay, signal qualities depends on the attenuations, noise, and also signal to noise ratio. Propagation speed, okay, determine the timing and the phase behavior of our signals that is being propagated. Repeaters ensure the signal can travel long distance without or less degradations. Okay, to say without is not quite 100% correct, as the system are not perfect, it's not ideal, but the repeaters will help us to reduce, okay, the degradations, okay, occurred to our transmitted signals after it gone through quite a distance. Optical fiber provide the highest speed and the best immunity to interference, okay, among the guided communications and also wireless communication. So we have gone through this and we have learned of this from our week 5 slides and also on our week 6. With that, I finish on presentations, okay, brief presentations on the week 6 slides part 2. Okay, thank you very much and have a good day.